Good afternoon, morning, evening, whatever it might be. Math Foundations 30 people. This is day 2 of our last unit, polynomial curves and quadratics and things like that. We got part 1 done. We were talking about the types of curves that we could have, and we did constant curves, and we did degree 1. And today we're going to do degree 2 and 3. We didn't do that yet. So that's what we're going to finish up today. And then maybe look at a couple of kind of questions that I ask when I do those types of questions for you. And we'll wait for this pop open and just kind of sketch what they look like and things like that. Okay, so it shouldn't be too long, but we will get to it today. So what are we going to do today? Let's hide this out of here. Let's get this up here. Okay, and what we want to look at is, let me just get my preview here so I can see myself at least. Don't like the fact that Screencastify took away the preview part where I could see what I was writing on the screen. Now it just previews the camera now. But I know it does because I checked it out. So I know that the screen is there. Okay, so sometimes if I accidentally block something out with my head, I don't really mean to, it's just that I forget. Okay, day 2, unit 4. Okay, and what we're going to be looking at today, we're going to be looking at degree 2, which is quadratic equations, which if you took pre-cal 20, you know what that is, or even in foundations 20. Degree 2 and degree 3 polynomial equations. Okay, and sorry. We're going to look at just some basic questions. So some examples, questions that I'll give in this area. Okay, so let's start with degree 2. Everybody's done these ones, I think, in the past. Degree 2, meaning that the leading coefficient x is squared, okay, is called quadratic equations. Okay. And lots of experience with quadratic equations if you've taken pre-cal 20 already, and a little bit if you've done some grade 10 math, that's in there as well. Okay, and this is basically when the leading coefficient is squared. Okay, so if the leading coefficient is negative, okay, it opens down, so that means okay, so that's low in quad 3 and 4, and the end behavior in quad 3 and 4 is down, or moving down. Okay, spell coefficient wrong here. Okay, if the leading coefficient positive, it opens up. Okay, so the end behavior is up in 1 and 2. Okay, and so let's do a little sketchy of it underneath here with my marker. Sorry. So if I have if I just do a little Cartesian plane x and y. Okay, quadratic. Okay, we'll go positive being black. Looks like that. Okay, negative, we'll go with blue. Now it doesn't always have to cross the x-axis like I'm showing here. Okay, it could be below that or an opening down. It doesn't necessarily have to cross that. The vertex could be right on the x-axis, but that's what they look like. Okay, positive is black, negative, that's the leading coefficients, by the way, if you're wondering. Okay, and then we'll just summarize kind of what we can have for characteristics. Okay, so it can be, we can say we already did the end behavior and we already did what the end behavior looks like. We could say that there's at most one turning point. Okay, and most of them have one. Okay, I guess we did I remember yesterday we did slashes there, so keep it the same. Okay, you can have a maximum of 2 x-intercepts. Okay, you could have 1, or you could have 2, or you could have 0. But you can have a maximum of 2 x-intercepts because of the degree 2. There is 1 y-intercept, okay? The domain, we'll do the domain and range here next. Domain is all values of x. Okay, and the range will depend on where the vertex of the parabola is. So the range will be a maximum or a minimum depending on whether it's blue or black there. So the range will be all values of y under the vertex you see that vertex being that top hill. For the blue parabola, for a leading negative coefficient, for let's just say the blue parabola, blue graph, and all values of y above the vertex for the black graph. And that's quadratics. Now the last one is cubic equations, degree 3. Okay, so we'll do it right here. Degree 3 cubic equations are called okay, and they have degree 3. So if the leading coefficient is positive, it climbs from left to right. Okay, so that means end behavior is low in quad 3 high in quad 2. Okay, and if the leading coefficient is negative, it falls from left to right. Okay, and that means it's high in quad 2. Okay, and low in quad 4. Meaning it's falling or dropping. Okay, so what does that look like if we do our little sketch again? Positive. Okay, so positive one that climbs from left to right. So it starts down low in quad 3, so down here, and high in quad 1. Or quad 2, pardon me. Or did I put quad 2? Did. It's supposed to be quad 1. Sorry, guys. Let's fix that. Fix that typing error. Click this over here and put a 1 there, not a 2. Because it's climbing from left to right. This is quad 1 right there, and then 2, then 3. So it's low down here, high up there. So that's positive leading coefficient. Okay, and then if we do negative in red, let's go. Okay, and it kind of goes like this. So it's going to fall from left to right. So it's going to start up high in 2 and finish low in. So it's going to go like this. Okay. So you can see it's low here in quad 4, high in quad 2. I got that one right. Okay. Okay, and then some of the other things that we can see in terms of the characteristics is that we have a max of 2 turning points. Could have less, could have only 1 depending on sometimes. And the other thing is it can have up to 3 x-intercepts. Okay, y, only 1 y-intercept. Okay, and then we can have the domain is all values of y, or all values of x, pardon me. And the range is all values of y. Okay, and I think that pretty much gives us cubic equations and quadratic equations. And that's as far as we go in this particular area. So now I'm going to do a couple examples of characteristics with it. So typically what type of problems I'll give you will be, I might give you a graph and say match the graph to the equation. I might say for each equation find this, this, and this, and things like that. So let's do a couple samples of those. It's not really very difficult. We don't have to graph them manually, but we kind of will be looking at, let's see what they got for practice here. It says, determine the degree, the leading coefficient, and the constant term for the polynomial. Okay, I forgot the constant term. I almost forgot. Okay, so let's talk about standard form here. Okay. One thing that the book's got in there is constant term. So standard form of a polynomial. So when you have a polynomial, the standard form is that you'll have f of x equaling something, or y equaling something, g of x equaling something, and then it goes from highest degree to lowest degree with the number without the x being last. So organize them in descending order with the number without the x term, or number being last. Okay. That last number is called the constant term. Okay. So descending is spelled wrong. Okay, so an example of that would be standard form of a cubic equation. Y equals x cubed minus 7x squared plus 4x minus 8. This is the constant term. And it also represents the y-intercept. Constant term is always the y-intercept because if you put a 0 in for x, you end up with a negative 8 for the answer for the y-intercept. Okay? If you do a squared term, negative 4x squared minus 7x plus 3, and this is the constant term there. Okay, ascending order, going from highest to lowest. This is a cubic, there's a quadratic, linear, and then of course the constant one would have no x in it at all. Okay, so that's a standard form of a polynomial. Okay, let's see what kind of examples we can get you to do here. Let's see. Okay. I might give you a question like this. So examples, we'll put some examples down. Okay. Decide, or what is the sign of the leading coefficient in each graph, or each sketch. 2 sketches, because I'm not going to be able to graph it perfectly. Is it, and then we'll say B, classify the equation as constant, linear, quadratic, or cubic, sorry guys. Okay, so let's do a couple sketches here. So I'll do a few of them. Let's do two. We'll do one here. One here. Might even say what is the domain and range, but you'd need them. And we'll do one in the middle here. Okay, so let me just draw a few. Okay, let's do some red ones too. We better not. We'll confuse each other. Okay, so let's answer the first one. All right, so what is the sign of the leading coefficient? So this one's climbing from left to right. Okay, so this would be a positive leading coefficient. Okay, and okay, it's got 1, 2 turning points. Okay, 1, 2 turning points. So that means it must be cubic. Okay, it's got the S kind of. Okay, this one here, okay, it's opening down 1 turning point, so that's a negative leading coefficient. And it opens down, so that's a 1 turning point. That's going to be a quadratic. Okay, this one over here, no turning points, crosses the x-axis once. It's going down from left to right, so negative leading coefficient. And it's linear because you have no turning points in it. Okay, and it's not a flat horizontal line. Okay, so that's one type of question they ask. Okay, so the other one they might ask something like this. I'm just kind of making sure that I don't mess up. So let's do a second example here. For each equation, state the degree, a constant term or y-intercept. I will call y-intercept. I'll just call it the y-intercept instead of the constant term. And sign of the leading coefficient, or the leading coefficient. Oh, yeah. Okay, so let's say we had something like, let's go 2/3 x cubed minus 7x plus 3. And let's say we had 9x minus 7, or y equals, I guess we should do 9x minus x squared. Okay. Okay, so this one's in standard form already. We're good. So the degree is third degree. Okay. The constant term is 3, so y-intercept equals 3, and the leading coefficient is 2/3, positive 2/3 leading coefficient. Okay, now if it's like this, you have to rearrange it in descending order. So this would be x squared negative plus 9x. Okay, then you can say to yourself, well, this is second degree. Okay, y-intercept is 0. Why is that? Because there is no constant term. There's no number without an x. So the constant term would be 0 because there's nothing there. And the leading coefficient is -1. Okay. Okay, that's typical one there that they have. What else might they have? Well, they might ask you, what is the end behavior? Let's add, what is the end behavior in here? Okay, so if we're going to do the end behavior for a cubic equation with the leading coefficient that's positive, it's going to climb from left to right. Okay, so it's going to be like this. Okay, so that's going to be the end behavior is going to be down in quad 3, up in quad 4, or 1, sorry. If we put the quads like that, right? You can also say that it's climbing from left to right. Okay. This one here, if we did the end behavior of this one, okay, so this is a negative quadratic, so it's going to go like this. So we can say opens down, or we can say that it's down in quad, two bottom quads, which are 3 and 4. Okay, so that's how you analyze them. Let's see if they've got any other ones that they might ask you. Okay, they might do matching of graphs, but I'll let you try that. Okay, so I'm going to stop there. That's about half hour. And I'll give you some practice. This is section 6.2, just identifying those things. So let's do a couple practices here. So 6.2, page 393 to 395. Okay, and I'll give you a few practice ones. So you can do like, let's do 1 and 3. Okay, so in there, they're asking you to just what we did, state the degrees and stuff like that, determine the sign, and then they do the same thing with graphs. It's kind of what we did, some examples of. Describe the end behavior of the polynomial function. So whether, we'll do number 5. Okay. And number 6 is matching. You can try that one. These don't take too long. Okay. 7, we'll do the odd ones. We'll do 7, B and D. Okay, now when they talk about the domain and range, they might write them in terms of set notation. Okay, so be aware of that. And just think of set notation back in Unit 2. Or you could describe it in words. Either way is good by me. And you can try 13. And that should be good. Okay. And that's the very first part of polynomial graphs. And then we're going to be looking at actual graphing best fit models, just kind of like we do in science when we do finding the best fit lines. Except we're going to do best fit lines that are linear, which is very easy because we're experienced with that. And then we're going to do best fit lines that are quadratics and maybe even cubic regression if we have time. And in order to do cubic regression, they used to use the calculator back in the old days, but we're going to be using Desmos for that. If we get that far. If we don't get into cubic regression, that's okay, but it's kind of interesting to look at sometimes. Okay, so we'll do that next day.